Neto, and this is Erlang, sorry, Elixir, Erlang, and the Bean with Adolfo Neto. Let me show you my screen. So this is the channel. I was reading today Elixir Radar, I don't know, issue 298, and this text by Rodrigo Caldeira. Rodrigo Caldeira shows in a step-by-step fashion how to integrate Elixir with a C library with a simple and didactical example. So I wanted to learn more about this because I have never tried this. So let me follow Rodrigo. Let me continue with Twitter. Yes. Okay. Hello devs, I'm Rodrigo Caldeira, software engineering at SumUp in São Paulo. I will share some thoughts about Elixir and NIF. This is my first contribution here, so please send me feedbacks about it. Okay. Yes, he talks here about Pix. Pix is a very nice system for banks here in Brazil, where you send money easily using a cell phone or even a computer. Okay, we have other events, Lunch and Learn, Hack Day. So this is the story in the case. And for me, more important, what I want to learn here is how he uses NIF's native implemented functions, which are actually from Erlang, not from, of course, the interface seems to come from Erlang, but the native implemented functions are in Rust or C. So Elixir systems run over the Erlang Bean virtual machines, and NIFs are the way to extend Erlang software through loading and executing native pieces of software. So if you can extend Erlang with NIFs, you can also extend Elixir with NIFs. So here this software can be written in any language that compiles to native components like Rust or C, so it can be any language. And in this example, Rodrigo, will create and use a library in C and use it in a simple Elixir module. So let's start with our native library. So let me go to desktop, to my YouTube. So I have Elixir, McDear, Rodrigo Caldeira, NIFs, CD, Rodrigo Caldeira, NIFs. What else I'm going to do? So there is this. Oh, this is not good, Rodrigo. It's in Portuguese. But let me try here. What's the name of the file? I don't want this full screen. But that's okay, Rodrigo. You are beginning. It's okay. Small mistakes. Okay. Oh, problems. Let me try code. What I don't like about code is that it gets some files from I don't know where. I just want files from this path here. But okay, it's here. Yes, it's empty. I'm going to copy. Okay. And libcalc C lib underline calc.c. So let me translate this. This is sum, subtract, multiply, and divide. I suppose that's the correct translation. So let me do the same here. Subtract, multiply, and divide. Okay, so it's only 4 functions in C. Here for non-Portuguese speakers, my guess is that the function's name should be straightforward, but here is the translation. Great. Now that we have our library defined, let's compile it. So let me try this. Like this up over here. Okay. Okay, let me. Yes, it's here, libcalc SO now. This is the compiled library. No errors, no warnings. Click noise. What does this mean? Click noise. By the way, I'm using Ubuntu on WSL2, for example. I'm using Ubuntu as a standalone system. Yes. Now it's time to test our library, and to do that, we'll create another C program that will receive 3 parameters: an integer number, the operator, an integer number. Okay, let me do the same thing here. What's the name? It's calc.c. No, calc.c. And then I will have to translate everything again. Sum, subtract, apply, and divide. Okay. And we have to compile it. I think it's better if we clear and okay, everything's okay, no errors, and then I can do this. I don't like this, but 1 plus 1, sorry, 2 times 3, that doesn't work. Why? I don't know. Two times 3, valid option. 3 divided by 1. It works. And which is the other one? It's minus 3 minus 2. Sorry. 3 minus 2 works. Why doesn't? That's the problem. You have to put backward slash. Okay. Now that everything is working, let's go back to Rodrigo Caldeira's tags. It notes that our calculator, I didn't do any kind of checking about the parameters sent to it. So if we run it with an expected input, this is the result: segmentation fault. That's okay for us, for we are not interested in the C calculator. So with all that ready, how can we use our library inside an Elixir program? The solution to achieve that, we need to write another C program that will represent our NIF to Erlang and expose our calculator library to our Elixir module. So this is a very big. What's the name? libcalc NIF C. Let me lib underline calc underline NIF.c. And oh, it's in Portuguese again. Let me somar. Let me replace it with some. Do I replace all here? And subtrair, subtract, all, multiplicar. Let me replace this with multiply, replace all, and dividir. Let me replace that with divide, replace all. Okay, what do I have to do now, Rodrigo? Let me just try to understand this. It's kind of saying, okay, we're going to have a sum NIF, subtract NIF, multiply NIF, divide NIF, sum, subtract, multiply, divide, Elixir calc, NIF functions, no. So it's basically, it's a kind of interface between the C functions and the Elixir module. Is it going to be an Elixir module? Holy moly, that's a lot of code for a simple library. Let's dig in. The first line includes our NIF is the baseline of our NIF. It's the header of all basic NIF libraries with the functions and macros needed to create the NIF. It's located in the Erlang dev package. After that, we have 4 more functions, each one representing the functions in our C library in a vertical point of view. What's a vertical point of view? So I will focus in only one of them, as the rest is basically the same. So these lines declare a new static function, called SOMARNIF, in our case SUMNIF, that returns an ERLNIF term. So this is the return type, a type that represents any Erlang term, and expects 3 arguments. ERLNIF env, pointer that represents an environment that can host Erlang terms. Let's consider it as the environment that's running our NIF. Int argc contains the number of arguments that was passed to the function, and const ERLNIF term argv are the arguments passed to the function. Okay, and this represents a lot like a regular main function in any C program, when you have to read argv to get the values passed to your function based on the number of arguments contained in argc. And that's exactly what's happening inside the function. So RC variables, int a, b, result are here. And this is the rest. So reads the first value and stores it in A, reads the second value and stores it in B. So it's using this function NIF getting it. And the result calls the function sum with A and B and returns the environment and the result. Here, argc is being totally ignored, as we already know that exactly 2 values are being passed as arguments. After defining all our NIF functions, we have to inform the Erlang NIF API how to call them. So it's here, sum, subtract, multiply, divide with 2 arguments, and it's using sum NIF, divide NIF that we defined before. An array of ERLNIF func struct. This struct is defined, struct ERLNIF func is defined as having the following variables: name, arity, and function. The NIF's function name that exposed in our NIF, the NIF function's arity, the pointer to the function that will be called when the Erlang Elixir model calls the NIF. There is a fourth variable, NIF funct struct, that's the flags, but for our example, it can be omitted. Where would those flags be? The last piece of code in our NIF is the NIF init macro call here. Macro call passing the module name, the functions that will be exposed in our NIF, and the pointer to functions dedicated to treat load, reload, upgrade, and unload events ignored here in our example. So NIF functs, it's this array, this is struct. Okay, notice that the module name is elixir.calc and not just calc. That's necessary because our goal is to use this NIF in an Elixir module, and all Elixir modules from the Erlang perspective start with Elixir. Phew, a lot of work here. Let's compile it and see what happens. So let me copy this. I'm going to compile. What happened? No errors. No, there's an error because it didn't find the erlnif.age. I probably have this, or I don't. You see, there's min here. What's the name of the file here? It's located in the Erlang dev package. Yes, maybe the problem is that as I'm using ASDF, it's not available. But let me do this copy. CP. This is going to work, I don't know, but let me just try here to remove or oh no, cd YouTube, Elixir, Rodrigo. Let me see if it's going to install all of Erlang. It's not going to be good. Let me try something else here. No, let me just wait. So let me, it's the baseline, okay. After that, let's see what I have going to do after that. And now the moment of the true, let's create an Elixir module. Let me try here to create this Elixir module. Calc ex. So in my case, I can again subtract, multiply, and divide. So, okay, let me see if it's working now. Yes. So this can be a problem because maybe Rodrigo, if you are listening to this, you can help us. How can I do this if I don't install Erlang this way? But okay, you gave the solution. So okay, now I have a very simple module that just let's read your explanation. Now the moment of truth. I believe there's no D here. Let's create an Elixir module. And this, dear devs, is our Elixir module that we'll call our NIF. Taking a look, you will notice this on load NIFs, def load NIFs, Erlang load NIF. Okay. This defines a callback that will be executed when the module is loaded on load NIFs. The callback will load our NIF. Let's see this in action. IX, and after that, C calc EX. C calc EX. I believe it's going to be yes, because it's I created the file with calc. Okay, it seems to be working. And now let me call calc sum 2, 3. Great. Multiply, divide, and subtract. And divide 3 by 2 is 1. So it's integer division. So it's working. Now notice all the other functions defined in our module. Yes, let me see. Calc. Oh, sorry. Continue. Calc dot divide. Oh, only one function, load NIFs. What do you mean by not so? Notice all the other functions defined in our module, they are just fallback functions. What do you mean? Just in case the NIF was not loaded for whatever reason. Ah, you mean that. Okay, I understand now. This if in case it doesn't work, it at least, oh, NIF sum not implemented, subtract not implemented, multiply not implemented, divide not implemented. Just fallback function, just in case NIF was not loaded for whatever reason. That's really great, but not so fast. There are a lot of things to be considered here before we move on with our excitement. First, remember how the arguments are declared in our C library. This function expects integer values. This behavior was passed all along with our journey here. In fact, our NIF tries to convert the first argument to an integer. What happens if we try to pass a value from another type, like a string? What? Let me try that with a float. So let's see what happens here too. It's because I'm using sum. Great. Why 1 here and 32753 here? I don't know. With a float. Let me call this again. Sorry, it's sum 1.0 to 1. It works perfectly. And here it works too. What's happening? No, it doesn't work because it should be adding 1 to 1, 2, but it didn't work that way. It's even worse because it gives a wrong return value and there's no error. What's happening here? Wasn't that if we keep calling the function with exactly the same value, the return value changes. That's because we didn't check inside our NIF to see whether the conversion was successfully done or not. So basically, here we are getting junk values from the conversion. as we are just trying to convert in sum, subtract, and ignoring the value. Subtract and ignoring the value itself, so this can do no harm to our module. But remember, we are dealing with C here, not Elixir, not Erlang. C, pointers memory. Can you imagine the scenario? Besides that, what if we try to divide by 0? Let me see. Sum divide 1 by 0. Oops. Floating point exception. The bean crashed. That's a huge problem with using NIFs. If the NIF crashes during the execution, the entire bean crashes. So this is a feature that must be used very, very carefully. Final considerations. So let me just, so these are the functions you are converting here. Yes, that's the problem. I'd really love to study this kind of topic, understand how the things work under the hood is a powerful method to discover new possibilities, explore and extend my knowledge about the subject. But that's it. As study case, I don't intend to put any of these things in production unless it's totally necessary. If there is no time to develop an entire feature that it's already implemented in native. Okay, so these are the cases he thinks it's totally necessary. If there is no time to develop an entire feature that's already implemented in a native library, if there is a bug in Erlang modules that prevents you to deploy your feature, if that native lib is so exclusive, so unique, and solves a huge problem, and there is no alternative to it. I think you got the point here. The source code of this project can be found at, and there is a bonus there. What's the bonus? Oh, in Go. That's probably the bonus. Same code. Is that? Let me close this. So this is Elixir, oh, sorry, yes. C code. C code. Okay, but what do I do with Go? I have no idea. So this bonus is not very useful for me. Oh, maybe the question is that it's so easy to do the same in Go that you can just do that and use the functions he defined in Elixir. So that's it for this video. Thank you very much. And if you have any questions, if you want me to read something else, just tell me. And bye-bye.